Hi everyone, welcome back to my videos. Today we are going to talk about module 5.3 if you are in IM3, but really that just means graphing cubic functions. So we're going to talk about the parent graph, or the one we start with, and then how to transform it. We're also quickly going to talk about, if you're given a graph, how you can write the equation. So first and most importantly, we need to talk about our parent graph. So a cubic function with no transformations is y equals x to the third, or if you want it in function notation, it would be f of x equals x to the third. Let's graph this just to remind ourselves where we're starting every time. So our parent function is going to be this function right here, and so we would input any value for x and we would cube it to see what we get. So the first really easy value is 0, right? So if I input 0, well, 0 cubed is 0. That's my first really easy point, so I'm going to graph that right now. Another really easy number to cube is 1. It's just going to give me 1. So again, over 1, up 1, that's my next point. Okay, and then another really easy one to cube is -1. If I cube that, it gives me -1. So I'm going to plot that. And you might see this and think, oh, this is just a straight line. We're going to connect all these. Not quite. Don't forget, this is like our John Travolta graph. It looks like in Saturday Night Fever, he's doing the disco, hands up and down. But really, we want to remember that this side of the graph is going to increase and this side is going to decrease. We can see that by doing one more value in our table. Let's do +2. If we cube that, we get 8. So if we plot that over 2 up 8, you'll see now that doesn't really follow a straight linear line. We now have our cubic shape. So I'm going to draw in my curve, and you can think of this as like our S curve, our John Travolta curve, whatever you want to think of it as, but this is like our base shape that we will be working with. Okay. Our 3 important points, or the ones we always want to think back to, are those first 3. So that's the 0, 0, the 1, 1, and the -1, -1. Okay, so we're always transforming from these 3 main points. You can think of the other ones as well, but these ones are really easy to work with. All right, when we transform this graph, we're going to have a bunch of values that we're going to look at and decide how they affect our graph. The first one, all the way on the outside, it's a factor that we multiply the entire chunk right here by. That's our a value. This is going to affect our graph vertically. This is our vertical stretch or compress. Vertical stretch and compress. Okay. Next is our b value. So you see right here inside the parentheses, so notice this value would be cubed. We can think of it also as it's with our x. This is going to affect our graph horizontally. So this is our horizontal stretch or compress. Horizontal stretch, compress. Okay, then we have our h and k values. You'll recognize these from any other function that you transform. H is going to be a horizontal slide or translation, and then k is going to be a vertical one. So h is going to be moving to the right or left, and then k is going to be moving up or down. So sometimes we'll have all 4 of these, sometimes we'll have one or the other, lots of different combinations, but just know that each one of these affects the graph differently. Okay, so let's try these out. We've got 2 graphs to try out where the parent function is already graphed, and we are going to transform it. So you'll see this is my transformation up here. I have an h value of 3, and I have a k value, careful, of 2. Now see, there's a negative and positive here, and that's what my transformation looks like. So that means whatever value there is my h and k value. If I had the opposite signs, then we'd have to make the number negative. We'll see that in the future. Okay, So I don't see any stretch or compresses. I don't see a negative, so we're not flipping this graph. So all we're going to do is slide or translate the origin of this graph. So normally we would graph starting at 0, 0, but we're going to move to the right 3 and up 2. So 1, 2, 3, and up 2. Then we're going to do the same thing with this point, to the right 3 and up 2. And last one right here, to the right 3 and up 2. Just like that. So then I'm going to remember my shape that a cubic follows and graph in my shape. So notice I didn't stretch this, I didn't compress it. All I did was take this parent function and slide it over here. And that's it. All right, next one, a few more things happening here. We've got a -3 on the outside. Notice this -3 is not cubed. So that means that that is our vertical stretch or compress. So I'm going to underline that in purple. I've got my H value. Ooh, this time is -2. I'm going to remind myself it's -2. And I've got a K value of -2 as well. So I'm going to remind myself that's down. Okay, let's try it out. So first, let's plot our origin, or that middle part, and then we'll go from there. So let me do this and do it in blue again. Okay, so normally we're at 0, 0. This time we're going to go to the left 2 and down 2. So left 2, down 2. Okay, and the reason that this middle point doesn't change with that stretch or compress is because these values were 0, 0. So if I multiplied those by any number, they'd still just be 0. That doesn't stretch or compress. That is going to affect the next couple points. So from this middle point, instead of, translating these over, I'm just going to work from this and remember that normally in my parent graph, I would go over 1, up 1. Now I'm going to go over 1, down 3. And the reason is because we stretch this by 3 and we have the negative. That flips our graph upside down. So then again, instead of going to the left 1, down 1, I'm now going to go to the left 1, up 3. Don't forget that stretch factor of 3. Okay, so again, try to follow that curve, but now with a more stretched out curve to it. And you can see that we have stretched this by a factor of 3, so it's longer, and we flipped it. That negative right here flips those values. All right, on the next page, we are now going to try writing an equation for this graph. So again, always pause the video if you want to jot something down before I try these out, but we're going to try writing the equation here. We're going to find out where that middle point is and see if we stretched it or flipped it, anything like that. Okay, so my middle point right here is at 0, 2. So I didn't move it horizontally, I did move it vertically up. So up, oops, up, gosh dang it, up 2, can't write right now. So that's my first value. The next one is a stretch. So I go over 1, down 1, over 1, up 1. I didn't stretch this by any factor, but I do notice it's flipped. So normally I'd go over 1, up 1. I went the opposite direction. So I know I'm going to make this negative. Let's try writing it. So y equals, and you can always do f of x as well. I know I want my negative. I don't have an h value, so it's just going to be x cubed. And then we went up 2, so I'm going to add 2, just like that. And then just wanted to show you guys that those original points, if it was the parent function, have moved, and now that new middle point is at the point 0, 2. This one has moved to, actually it's still 1, 1, and then this one is -1, 3. Like that. All right, let's try the next one. So this one has definitely slid over to a new origin point. We have to the right 3, I'm just gonna write that in blue, right 3, we know we move up 1, Okay, I have my traditional S shape, so there's no negative in this one, but I do see something going on with a stretch or compress. So again, always remember from the middle point you go over 1 up 1. But now I'm going over a half up 1. So that affected my x values. So I have a b value of 1/2. Okay, let's get to writing. So I'm going to write this in blue this time. We've got y equals, and then that b value is going to be in parentheses. So I've got 1 over 1/2. Hey guys, if I write 1 over 1/2, that just equals 2. So I'm going to write 2x minus 3, and then we have up 1, so plus 1, just like that. So again, showing where my points moved to. That original 0, 0 is now at 3, 1. This point is now at 3.5, 2. And this point is now at 2.5, 0. So you'll see how those moved. All right. And then again, really good practice writing our equations, but now from some word problems. So instead of looking at a picture, we're just going to read what's happening. It says the graph of f of x, x to the third, is reflected across the x-axis. That tells me I'm going to have a negative in my equation. It says the graph is then translated 11 units up and 7 units to the left. Write the equation. Okay, so I know I need a negative. F of, actually let's do h of x, since this is a transformation. Equals, I know I need a negative for the reflection, and we are moving 7 to the left, so that's x plus 7, and then up, so that's plus 11. Okay, for the next one, it says it's stretched vertically by a factor of 6, so we've got 6 on the outside, and then 9 units to the right, that's x minus 9. Notice the 6 is not cubed, it's not in the parentheses. And then we've got down, so minus 3. Just noticing, in case you guys were copying down this one, this 2 needs to be in parentheses like that. That 2 needs to be cubed. So just wanted to make sure that was apparent. When it's vertically, it does not need to be cubed. Like that. Okay, thanks so much for watching, guys, and in our next video we will graph some different types of functions.